Space sustainability is the thinking of how do we ensure that our atmosphere and orbits, along with other extraterrestrial bodies, can be preserved and used for as long as humanity exists. There are two main sections of space sustainability: short-term and long-term. The short-term sustainability primarily has to do with Earth's atmosphere and low Earth orbit. The main issue that we are facing today is the amount of space debris in our atmosphere. Space debris is any human-made object in Earth's orbit that no longer serves any useful purpose. So that makes sense. How much more space debris is there in Earth? As of 2022, NASA records that there are more than 25,000 objects larger than 10 centimeters in diameter. However, there are around 500,000 objects between 1 and 10 centimeters in diameter. And the particles larger than 1 millimeter are roughly 100 million in number. Safe to say, there's a lot of debris in space at the moment. So how fast can this debris travel? Again, according to NASA, these objects normally move around 7 to 8 kilometers a second. However, impact velocity on objects can be as great as 15 kilometers a second, or 10 times the speed of a bullet. So this means that any particle, even the smallest millimeter-sized particle, could cause extensive damage to a satellite or a human in space if not properly accounted for. So there's a lot of space debris in space. So what? In 1978, NASA scientist called Don Kessler came up with a theory called the Kessler theory that stated if enough satellites are put into space, eventually some space debris will hit one of these satellites, creating more space debris. And at a certain threshold, this space debris will create a feedback loop by hitting more satellites at fast enough speeds to create even more space debris, which theoretically could make it almost impossible for satellites to stay in this orbit without getting severely damaged or incapacitated, making the cheapest realm of space almost impossible to maintain. However, if a rocket is launching straight through the low Earth orbit into deeper space, it should not pose as serious of a risk, as the rocket and payload will not be in low Earth orbit for a significant amount of time. However, it would set the space industry back several years as we wait for this debris to burn up in Earth's atmosphere. If you want more information on the Kessler syndrome and its ramifications for space exploration, please view the resources provided. As we move from our short-term space environmental goals and objectives, we then can look at our long-term space environmental goals and challenges. There are 4 main environmental challenges in outer space. The first is how will we preserve our extraterrestrial surfaces so that future generations can explore and enjoy them. The next is how will we as a species sustainably extract resources from these other planets so that we do not destroy the planet's possible ecosystem and landscape. Then, how will we colonize these planets sustainably and safely and socially justly, so that these colonies do not contaminate the surfaces of these alien planets with Earth life, so that we can preserve the virgin nature of these planets. To find out more about how humanity is looking to answer these short-term and long-term space environmental questions, please look at what the UK is doing for space sustainability on the next page, and some resources have been added to this page as well if you are at all interested.